Good morning students. In the previous class, we see the concept of the conditional probability. Now we move to the fourth exercise, that is the last exercise. But it is also important, just over the 10 sums is there. All the 10 sums are important 5 marks. Definitely sure one question will be asked in the exam. So there will be two concepts are very important, that is called the formula. The one is the total probability of an event. Another one we use one theorem, the name of the theorem is Bayes. First we see these two formulas. In exercise there will be 5 problems. In exam also there will be 5 problems. All the 10 problems are very important regarding 5 marks. So first we see the concept, the total probability of an event. For understanding, I will draw one diagram. So full box is a sample basis. We say one circle. It is fully one event is a P. And outside so many events is there. I will put the name is A1, A2. This part is A3. That means this part is A1 and that part is A2, A3. Suppose this part is AI. And what will be the part? You see this part? In sets, you know very well, this part is common in, you see, a B and A. So how to write in common? How to write here? I write here A1 intersection of B. Okay? This one is common in both B and also in A. So intersection of this one. Now we need the total probability of B. But B will be after either A1, A2, A3 like this. Okay. Now we see the formula. If A1, A2, A3, etc. A and R mutually exclusive and exhaustive. Okay. There is no connection of all the events. Mutually exclusive and exhaustive means so the sum of all events value should be equal to 1. And B is any event in S, then P of B is called the total probability of S. Total probability of the event S, then the value of P of B. The formula of P of B, how to find? P of A1. That is, first, the B lies within a part of A1. And P of B by A1. I have no place, I continue here, plus. This one is possible. Or, suppose the say B is lies in A2. So P of A2 and P of B by A. Consider in the second set, and B already will take the second set. So it's a conditional probability. So this process is going up to the last one. P of A, P of B by A. What is actually next step? P of A3 into P of B by A3. So we continue this process. The last step is P of A and P of B by A. So it is the formula of the total probability of an event B. So P of B formula is P of A1 into P of B by A1. Plus we move the process up to the nth event. Next step P of A2 into P of B by A2. What is actually that step? Plus P of A3 into P of B by A3. We continue the process up to n times. So it's the first one. Next, we use one theorem. The inverted name is a Bayes. So the name of the theorem is a Bayes. Here also A1, A2, A3 allow up to A and R mutually exclusive X or events. Such that all events are greater than 0 when I put I. The value of I from 1 to n. And B is an any event. B is an any event. Suppose we need P of AI by A. Already the event B is there in AI. So the formula of P of AI by B is nothing but P of AI. We write here AI is there, so I put AI. Is P of B by AI whole divided by AI is there, so I write P of AI. Suppose A1 is there, I write P of A1. A2 is there, I write P of A2. And divided by the total probability. You know very well what is the formula of P of A? N of A by N of S. Where N of S is the total probability value. Here also we write all the total probability value. That means this is the total probability value. So in denominator we write all values. So P of A1 it will P of B by A1 plus second step P of A2 into P of B by A2 plus etc. is going on. On certain stage P of AI into P of B by AI plus etc. I have noticed plus last step is P of AN P of B by A. So this is called the base theorem. Okay, P of A by B is that, then whose formula is P of AI into P of B by A divided by the total probability of A is nothing but P of B. All denominator is nothing but P of B. So now we see there will be two formula. The one is a total probability of the given, and another one is using base theorem. So these two formulas are very important in the following problems. Okay, now we see the first one. Next is 4.4, the first question. We must understand the question very fast, and then we solve the problem. If the questions are you understand very well, then the answers are very easy. Now the concept question. A factory has two machines, so 1 and 2. So a factory has two machines. The name of the machine is given 1 and 2 raw material. Machine 1 produces 60% of items, and machine 2 produces 40% of items. An item. Suppose a factory manages 100 items. First machine produces 60 items, and the second machine produces 40 items. Further, 2% of the item produced in the machine 1 are defective. Defective means some damages. 2% of the item produced in machine 1 are defective, whereas 4% produced by machine 2 are defective. It is in machine 1 and machine 2, some very few of the material, that is items, are defective. That is a chance. Then the question is, if an item is drawn at random, what is the probability that it is a defective? So the machine manufacturing item are mingled by the machine 1 and machine 2. Suppose there are so many items are there. For example, 100 items is there. We will take any one of the item at random. Suppose if it is defective, what is the probability? That is a chance? Yes, it's a very rare chance, but it is a chance. But the item may be produced by machine 1 or machine 2. So there will be two chances there. So we involve in conditional probability. First we will take the name of the events. First I will take the name of the events. Let A1 and A2 be the events. That the items are produced by machine 1 and machine 2 respectively. First I will put the name of the events. A1 and A2 be the events that the items are produced by machine 1 and machine 2 respectively. Suppose an item is produced by machine 1, all the items names are A1. Suppose the machines are produced by the second machine, we will take the name of the event is A2. And also some of the item, defective item is also there. So if we take the name of the defective item is B. Let B be the event of drawing the defective item. Suppose if we take one item, it is a defective, then the name of the event will be taken is. So these two lines are very important, we must write this. I write in many words, but maximum we take the event's name is, so names are there, A1, A2, A3, and I mentioned the event will be taken is because all formulas are not A1, A2, A3 up to B. So I will take this A1, A2, B. And some values are given. Here, some values are given. Now we write the values. What are the values? P of A1 value is given, where A1 indicates the A1, the item is produced by machine 1. How many percentage of machine 1 produce 60% of item? Machine 1 produces 60% of item. So P of A1 is 60%. 60% is nothing but 60 by 100. Now there is a chance to cancel. I don't cancel here. I simplify the last one. Next, P of A. Second machine produces 40%. 40% is nothing but 40 by 100. So these two data are given. One more data is also given. Defective items 2% and another one is 4%. So this events also write in probability form. I will write it is P of B by A1 and another one is P of B by A2. It is a conditional probability. What event is already happened? A1 is already happened, then the event of B. That is, the item is already chosen in the first machine. Suppose if it is defective. In first machine, how many percentage of items are defective? For the 2% of item produced by machine 1 are defective. So there will be a 2% are defective. So how to write the 2%? We write the 2% as 2 by 100. The second one, whereas the 4% produced by machine 2 are defective. How many percentage? 4%. So I write it is 4%. What is the reason to take conditional probability here? Already we assume we will be taking the item is manufactured by the machine 2 and also it is defective. So this is 4%. We write 4% is also 4 by 100. Now what is our question? To find in which value this is important. It's a given in word we converted in a symbol form. Now we find if an item is drawn at random, what is the probability that it is a defective? We will be taking the name of the event, it is a defective. The defective event name is B. So to find P of B. Next, we write the formula. We know that P of B, that is a total probability of an event. We assume the probability of taking a defective item. Suppose the defective item is come from the machine 1 or come from the machine 2. Suppose it's come from the machine 1, we write P of A1 into P of B by A1. First machine, we will be taking the defective item or is nothing but plus. Suppose the defective item come in the second machine position also. So P of A2 into P of B by, we know all the values. Now we substitute all the values. What is the value of P of A1? The value of P of A1 is, you see, 60 by 100. P of B by A1. The value of P of B by A1 is 2 by 100. Plus P of A2 is a 40 by 100. Then P of B by A2, the value of P of B by A2 is a 4 by 100. Is 120 by 10,000. Okay. 60 into 2, 120. 100 into 100 is 10,000 plus 4 4 16. So 160 divided by 10,000. You see, in both the term, denominator is 10,000. So no need the question now. So you will simplify. Now we simplify, what is the answer? You see, in both the term, the denominators are same. So no need the question. I will answer. In both the term, denominator is 10,000. So we add the numerator. Suppose we add the numerator, we get 120 plus 160. 400 by 10,000. both are we get, add we get 28, 0, 12 plus 16 is 28, 0, 1, 2, I cancel 1 zeros, 28 by 1000. Classification process is easy one, we write 28 by 1000, or we write in decimal form, P of B value is 0.028. So which is the required property. That is, the property is occur at chance very rare. Because factory manufacture an item is always non-defective. In 100 pieces, suppose exactly 1 or 2 will be there. So we will be taking any one of the item. It is a defective chances is a very rare chance. Suppose if it is defective, the chances is 28 by 1000 or 0.08. Now we move to the second one. You see the consideration. There are two identical ants containing respectively 6 block and 4 red balls. 2 block and 2 red balls. An ant means one kind of vessel. So 2 vessels is there. Both are in identical vessel. Identical means there is no difference of these 2 vessels. Some balls are put in the vessel, that is ant. In the first ant, 6 block and 4 red balls are there. In second ant, 2 block and 2 red balls are there. An ant is chosen at random. So you will be taking any one of the ant, maybe the first ant or the second ant. And a ball is drawn from each. So you will be taking a single ball, either the first ant or the second ant. That means without seeing the ant, we will take one ball. Then our question is, find the probability that the ball is black. What is the find the probability that the ball is black? It's the first one. Suppose we will be taking one ball. Out of this 2 ant, any one of the ant, it is a black. What is the probability? It is the total probability. The black ball will come in and 1 or and 2. That is the total probability. And second one, if the ball is black, we already assume this event is already happened. We assume the ball is black. The ball is black. What is the probability that it is from ant? We are taking one ball. The ball is black. Suppose it is come in and 1, what is the probability? So it is a conditional probability. So we understand this question. Then we put the answer. What is the first step? You write the name of the events. How many ants are there? There will be 2. So if you are taking a ball from first ant or the second ant. So first ant ball will be taking the event is A1. Second ant will be taking this A2. So let A1 and A2 be the events. A1 and A2 be the events. They are selecting the ball is come from N1 or A2. Either events. Getting a ball from N1 and N2 are respective. The meaning of this line is, suppose we will be taking a ball from N1. We will be taking the name of the event is A1. Is coming N2. The name of the event is A2. Is the first step. Next one. All the values are involved in black. Here also black. Suppose the ball is black, we put the name of the event. The name of the event is B. Let B be the event of getting black. Suppose the ball is black, whose event name is B. What is the total balls in N1? In N1, the total ball is 6 block, 4 reds. So 6 plus 4 is equal to 10. And second one, in second one, 2 block and 2 red balls are there. So 2 plus 2 is equal. The number of red balls are important, black balls are very important. In first hand there will be 6. In second one there will be 2. So out of this 10 ball, we will take any one of the black balls. In second hand, out of 4 balls, you take any one of the black balls. Now some data are given. What is the value of P of A1 and P of A2? These are important. There will be two answers there, both are identical answers. What is the chances of taking a ball in from hand 1 and hand 2? What is the chances? Both are in equal chances. You will be taking either hand 1 or hand 2. So 50%. You see the word is not given in the question. You must understand there will be two hand only. So equal chances of getting a ball from hand 1 and hand 2 is a chance. So equal chance, that means 50%. We write how to write 50%. We write how 50% is nothing but 50 by 100. So 50 by 100. Next one, some easiest values is there. Now I can say this is the simplification. So P of A1 is 1 by 2. And P of A2 also 50 by 100. I cancel. P of A2 is also 1 by 2. Wow. P of A1, P of A2. So many values is also given in the question. The first hand contains 6 black and 4 red balls. So the conditional probability I write also P of B by A1, that value is given. What is meant by B by A1? It's a conditional property. Already one event is happened. That is, the ball is come from hand 1. B is the event of getting a black ball. So what is the value of B by A1? And 1 contains total number of balls is 10. So whole divided by 10. That B is the event of black ball. How many black balls in the first hand? 6. So out of 6, any one of the ball will come. So we write is 6 by 10. So we cancel, we get P of B1 is 3 by 5. I cancel all possible events. So I cancel here also. So 6 by 10. I cancel, it is 3 by 5 in second term. P of B by A. That value is also given. It's a conditional probability. One event is already happened. Which event is already happened? The event is the ball is come from hand 2. In hand 2, what is the total number of balls? In hand 2, the total number of balls is 4. So 4 divided by 4. B is the event of selecting a black ball. In hand 2, how many black balls is there? 2. Or right here 2. So 2 by 4. I cancel. Or I write P of A2 is also 1 by 2. Yeah, 1 by 2. Is all the given value. We will be taking understanding of the question. Don't memorize the concept. All are the important concept. See in the question. Then we write the event's name. Then all values is there. Next, to find two submissions. Submission 1 and submission 2. I write both the submissions. So to find. It is given in word form. Now we write in a symbol form. Okay, what is the first submission? You see the question? Find the probability that the ball is black. Only one line. That the ball is black. What is the name of the event? Suppose the ball is black. The ball is black. The event name will be taken as B. Will be the event of getting a black ball. So to find, yes, P of B. So to find the first one, P of B. Second one, I give one clue. It's a conditional probability. One event is already happened. Second submission. If the ball is black, already we assume the ball is black. What is the probability that it is from the first hand? So it's a conditional probability. If the ball is black, so on the right, P of this event is already happened. So I write this P. What is the reason to write P here? If the ball is black, but the black ball is come from in which hand? first term. First term event, if we take the name of the first term event is A1. So P of A1. So to find this two. Suppose this question, the second submission is question. If the ball is black, what is the probability that it from a second hand will come? Suppose second hand will come gives, we find A. But it is from first hand, so it is P of A1 by A. So now to find these two values, these all values are given in the question. We must write all the values, then to find these two values. Where the first one is nothing but total probability of the event, P of A. And second one is the conditional theorem by Bayes' theorem concept. We find a P of A1 by A. So first to find the total probability, and the next to find the Bayes' theorem P of A1 by A. First we find P of A. You know the total probability of P of the formula is P of A1 into P of B by A1 plus 2n is the P of A2 and P of B by A. Let's stop here because there will be 2 and 1 is there. So it comes from the first and or the second. All values is there. We use a value P of A1 1 by 2 and P of B by A1 is a 3 by 5. So 1 by 2 into 3 by 5 plus P of A2 is also 1 by 2. Here P of B by A2 is also 1 by 2. 1 3 is 3 by 2 5 is 10 plus 1 by 1 2 is 4. There will be just 2 number. I cross multiply, I get 12. Okay, cross multiply, I get 12. 10 ones are 10. We cross multiply, so we multiply the denominators. 10 4s are 40. So 12 plus 10 is 22 by 40. Now that is a cancel in a second table is possible. I cancel. So P of B value is 11 by 2. So first one answer is over. So total probability of event is 11 by 20. So first submission is over. Now we move in the second submission. What is the second submission? P of B, P of A1 by all values know I write. So over there the concepts there I write the second submission. P of A1 by B. How to find P of A1 by B? By using the Bayes theorem. Bayes theorem P of A1 by B. I already write the formula of Bayes theorem. What is here factor here? A1. So first we write the P of A1. Then P of B by A1. If A1 by B is the P of A1 into P of B by A. Suppose A2 is the P of A2 into P of B by A2 divided by the total probability of an event. The total probability P of A1 into P of B by A1 plus P of A2 into P of B by A. It is a total probability of an event. Now we apply the values. P of A1, the value P of A1 is off. And P of B by A1, the value is 3 by 5. I say it is a value of P of B, okay? P of A1 into P of B1 plus P of A2 into P of B by A2. This full value is nothing but P of B. So I write it is P of B. We have to find the value of P of B, so we use. Now I see that is no one is cancelled is a chance. We multiply the numerator as it is. 1 3 is 3 by 10, okay? 2 5 is 10. By P of B, the value of P of B is 11 by 20. So 3 by 10. I take the reciprocal. The denominator term goes to numerator as a reciprocal. 11 by 20 become 20 by 11. 1 time, 2 times. 3 2 is 6. So 6 by 11. So it is a value of P of A1 by A. So total probability of even P of B value is around by 20, and the ball is a black. Suppose from the pan 1 the probability is 6 by 11.